integration the process of taking variables from out of equations, e.g. ax to the b, which is the most common variable type, and you take that out of the equation and you solve them individually. Theoretically, the use is to be able to take stuff such as dy by dx or the gradient function or derivative and then be able to convert it back into the f of x format. So the most common way for integration is mostly ax, so zax, sure, let's just keep it as that, or as you may see it, ax to the b. So ax to the b is more complicated theoretically because you don't have any values, but obviously here there are values, 5 and 8. So theoretically, integration is the process of taking the power, so taking the x and adding 1 to it. That's because when you do differentiation, you subtract 1, so it is the literal opposite of it. So subtract 1 in differentiation, add 1 in integration, and what you do with that new value, so that x minus what, x plus 1 value, is you divide that by your number in front of the x. So minus 5 over that x plus 1 value, and then that is basically your new equation. That is the x plus 1, so the thing you had previously, and then on that thing you had previously you divide it by the square basically. So in this case 3x to the 5, you take the root and you add 1, so 5 plus 1 equals 6. You then take the number in front of the x and you divide the new power by that number, is a half. And then you combine these variables together with the x. So it's a half x to the 6. And that is literally it. Why this works is when you do dy by dx or differentiation, what you do is, say you have 7x to the 4. What you do is you times these values together. So 7 7 4 28 x, and then you just take 1 away from this, so that's 3. So in integration it is literally the opposite. It is adding that 1 back onto this 3, so giving it 4, and dividing that 28 by that 4, so 7x to the 4. But then what happens if you have something like when you do dy by dx of 8, you just get nothing, it just goes away. So for that reason, whenever you do integration, you have to have a plus c on the end of it. That plus c is a constant. It kind of connotes the idea of there is something else there probably. It could also be a 0, but we just don't know what it is. So the basics are, we have 3, we have none, and we have 5x, and we have 3x to the 5. And theoretically they're all used in. So these are the 4 basic variables that you will need to know. For 3, for any just normal number, for any constant number you just add an x on top, so it's 3x. For none, that means nothing there, you do plus c, because you don't know if there's a variable there or not, because in dy by dx it just could have gone. For 5x, you add 1 on top, so plus 1. So there's already an imaginary 1 there, so you plus 1, and that makes 2. Then it's 5 over 2 x to the 2. And finally, these ones, which have an actual number in front of them. So it's 5 plus 1, which is 6, and there's 3 over 6 x to the 6, so half x to the 6. And the way of checking it is just going backwards and doing dy by dx on all of them. So say if you were to do dy by dx of this, you'd get 3 because you're taking away the x. dy by dx on plus c, plus constant, just goes away. dy by dx of 2.5x to the 2, you times by 2, so it's 5x, because you then minus 1 again, so that does that. And here 6 times a half is 3x to the 5, and that is integration in literally 5 minutes.